So if you do have to leave a little bit early or you miss something, you'll be able to view it later. I've already sent the slides over to Mike, so he'll be able to distribute those after the fact. And the practice material will all be uploaded here on RStudio Cloud. So if you go to RStudio Cloud and then click on the primer space, you'll be able to see these different practice sets where you're able to write code. You don't have to do any installations or anything. You can just instantly get started practicing with our both the basics all the way out to Tidyverse examples. To give you a quick background about myself, my name is Thomas Mock. I work here at RStudio on the customer success team. So I work with groups like yourself to give webinars and do customer education with regards to both RStudio's professional products and the open source products like the Tidyverse. The kind of goal of today is to give you kind of a whirlwind tour of the Tidyverse. So it may be kind of quick, but I will definitely be sharing all this material with you to follow up and kind of just giving you a nice overview of what's possible with the Tidyverse. So for today's agenda, I'll be going through examples of RStudio, the development environment. So examples of writing code, bringing files in and package control, some basic things about R coding, so doing math, assigning variables and assignment to objects, loading functions and using functions, as well as packages, which are meta collections of functions. And then obviously the Tidyverse, where we kind of, the basic idea is that we read data in with things like readr, we tidy data, which means to make it in the tidy format with Tidyr, transform data with Dplyr, and then plot that data with ggplot2. So RStudio itself is an IDE, which just means integrated development environment. If you're used to, Excel or something, it'll be kind of a nice GUI interface or graphic user interface, kind of like you're similar to Excel in terms of you're able to type things and interact with your data there. The big benefit, though, is that you're writing code instead of clicking a lot of buttons. So this means that it's a little bit more reproducible because it shows you exactly what you've done. And if you need to share exactly what you were doing, you could actually share an R file with someone else, and they could rerun it and get the same output. So RStudio is a place to write. So there's the console where you actually write code. You can also write code in R scripts, which is kind of like a text file where you write code and it gives you an output. Or R Markdown, which is where you can actually write comments and write a lot of words or descriptions of what you're doing, in addition to writing code that is executed. RStudio also allows for code completion. So, if you start typing the first few letters of something, it'll complete it for you. And it offers debugging. So if there's an error that is thrown or you type something incorrectly, it'll help you out in terms of telling you what went wrong. RStudio is also a place to open things. So you can navigate your file system and explore paths. So you can open a file, whether it's data or a plot or an image, as well as R and R Markdown files. And lastly, it's a place for projects. So this gives you a self-contained structure, which provides consistent and easy pathing. So rather than having to navigate to a weird position, you basically just keep all your files and your code together inside of a project. And when you're working inside this project, it allows you to keep all those things together that need to be. So you write code, you get an output, and the input is all stored there with it. In terms of what RStudio looks like, this would be the main pane when you either install it or access it on something like RStudio Cloud. So here in the top left corner, we see the editor. In this case, I'm editing a .r file, which is an R script. So you can see I have an example of writing a code here. I'm loading the library ggplot2, and then I'm calling some ggplot2 code, which creates an output graph here in the output pane, which would also be in the plots tab. Additionally, you can also write R code that's evaluated inside the console. You could do this for quick code if you're just trying something out, but in this example, you would kind of lose it after the fact. You run it and then it's not editable, versus here in an editor, you can write code, delete code, and add things in, and then evaluate it. The last pane I want to show real quickly is the environment pane. So once you save something into RStudio, it'll show up here. So if I assigned this graph to an object, say like G, G would show up here, and then I could run it by just clicking G. Additionally, if we go into RStudio Cloud, this would be the basic example. So it's going to be almost identical to the desktop version. In this case, I'm using an R script again. So you can see I have a comment up here. I'm doing some assignment and some math. We can contrast this to an R Markdown document, which actually has a lot of written text, and then this special code chunk, which says this is an R code that we're evaluating, and then I run my code inside here. So only things that are written inside these code chunks are actually evaluated, versus things on the exterior of that are just evaluated as text. So you can write like, this is what I'm doing for today, run some code, and then below that, write what the output was. It's a little bit more of putting your code with written word. As I mentioned, RStudio provides some diagnostics, so you can see some syntax error. So here, if you do something incorrectly, it'll show you there's an error there because you need this to be either compact or a different name for it. You can also hover over this X that shows you there's a problem, and it'll say there's two tokens here that are going on. They need to be smushed together. And lastly, it also gives you warnings about potential problems. So, if you're trying to write some code that's not great, it may evaluate it and tell you, hey, this is the proper way to do it. And as we talk about mistakes, I want to let you know that everyone makes mistakes. So especially as you're learning either a new library in the Tidyverse or you're learning to code, people are going to make mistakes, and it's okay. Like, it doesn't break anything. You just need to change something and reevaluate it. So in this example, I'm assigning x, which is a variable, multiplied by 3.14 to the object myVariable. I then try to call that object by typing out myVariable, but I misspell it. So I type a 1 here instead of an L. R doesn't know what this is because it's misspelled, so it gives you a warning. And all we have to do is correct the spelling and make it say variable instead of variable with a 1, and it will then evaluate that code properly. So this will happen, and you'll make these mistakes whether you're new to R or very experienced. It'll happen, and that's okay. Like, just keep improving as you move along. R itself is essentially the most aggressive spell checker of all time. You have to match up parentheses. You have to spell things the correct way, but it'll often guide you forward, saying like, here's the error. And if you don't understand what the error means, you can always just Google that exact error or ask a colleague, and they might be able to help you out. As far as writing our code, so if you go into the basics, I spoke about assignment briefly earlier. So in this case, we can do some math. So we'll do 3 multiplied by 4 and assign that to x. If we then call x, it'll return the output of that. So 12, 3 times 4 is 12. We can keep x and move it forward. So y and now is going to be assigned to 5. If we multiply y by x, 5 times 12, we get 60. So all of this is evaluated, and you kind of understand what you're doing with taking something and assigning it to an object. You can also work with data rather than kind of assigning individual pieces. You can create what we like to call data frames, which are kind of a tabular view that's more similar to something you see in Excel. So you have columns, column 1 and column 2, and then rows. So in this example, I created 1, 2, 3, A, B, C in column 1 and 2. And you can see that it actually created those columns and rows as I created them earlier. And this is the basic data structure that we're going to work with within the Tidyverse, is a data frame. So this tabular view, rectangular data, that this should be fairly similar whether you're experienced with R or just getting started. The next part, and what kind of makes R really powerful, is you have these things called functions, which is essentially shorthand to call specific code. So in this example, we have a fake function. I'm just going to say function name, and it takes arguments. So argument 1, argument 2, argument 3. And so this could be inputs to the function to tell it what you want to do. So in the example of this function sequence, this creates a sequence of values from a starting value to an ending value by something. You can also do length out and along with. I won't talk about those as much, but I'll give you a quick example. So if you take the sequence function, you say, I want to go from 10 to 100 by 10. So it'll go 10, 20, 30, 40, 50, all the way out to 100. You can contrast this with using the argument length out, where it would actually give you a set number of numbers it's generating. And specifically with functions, you can either do this where you're telling it explicitly, like I want from to be 10, to be 100, or you can do it by position. So because from is first, to is second, and by is third, you can do the same thing with just 10, 100, 10, and it will know that 10 means from, 100 means to, and 10 means by, and it gives you the same output. But if you want to add, say, your third element to length out, which is actually the fourth element, you need to, again, explicitly say, I want length.out to be 5. So in this case, rather than going to every 10, it's just creating a group of numbers of length 5 from 10 to 100. So 10, 32.5, 55.0, 77.5, and 100. It's just a really quick example of functions. We'll be talking a lot about functions with the Tidyverse and in other examples I'll show you in a second. The other thing I want to talk about is the pipe, which is equivalent to saying and then. It's really commonly used in Tidyverse and in other examples of R packages. And this is just a way of doing kind of an analysis with, rather than using multiple assignment or nesting functions, just doing it in kind of a linear path forward. So in this fake code I have here, we're doing something to some data and saving it as the did something object. We then do another thing to that object, and we say reassign it. And then we do one more thing to that, which is the last thing, and reassign it. So this is fine, like this evaluates properly. It's just a lot of different objects. So alternatively, you could do nesting functions. But this is a little bit more difficult to read because you're taking data, doing something to it, doing another thing to it, and then do the very last thing and assigning that. So it's actually reading from inside out as opposed to down or linear. And then lastly, the example I'd like to focus on is the pipe example. So here we're taking data, and then we're doing something to it, and then doing another thing, and then doing the last thing and assigning that all to the final object. So it kind of gives you this linear path forward where you take data, you write some verbs about it, and then you keep doing things and assigning it back to the original object. All of these give the exact same output, but I like to think about this because it makes more sense to me in terms of a linear path. If you think about the pipe, again, it's going to say as and then. It's basically passing the left-hand side forward. So this dot is shorthand for this. So this dot is equivalent to this. This dot is equivalent to this object after it's been done. And lastly, this is passing the left-hand side forward from the previous line. So, data do something where data is equal to the dot, which is basically saying whatever's before it. You can also, explicitly just do it by position, or you can just kind of drop it completely because it already knows that this data is going to occupy the first space. So yes, you could explicitly say it, but it already knows ahead of time. You can just do data and then write your function ahead of it. So doing back to our example of sequence. So if we did multiple assignment, we would take the sequence example. We want to go from 10 to 100 by 10. We assign that to data in. We then take the mean of that vector of numbers and save it as result out, and then call result out, which gives us a mean of 55. We could do our nested function where you, again, take the sequence from 10 to 100 and take the mean, gives you the same output. Or we can do it with the pipe where we create the vector and then we take the mean of it, which again gives us 55. So all those are examples of legitimate code. I just like to think of things as going down in this linear path. And again, you can always assign that. So doing the exact same thing here, but assigning it to the mean output and then calling the mean output again. All of it gives you the same code in the same example. We go to a little bit more complex example and we take a data set like this, which is a fake data set I created that might be similar to some of the stuff y'all are working on in terms of labor statistics. We have a data set here where it has multiple years, it has male and female gender, and then some age groups. So less than 18, 18 to 30, 31 to 50, 51 to 60, and then greater than 60. And then it has their income moving forward. So this should be pretty similar to you in terms of it's a data set that makes sense. You have year, gender, age group, and income as your columns, and then each of the rows is an observation within that column. If we apply some quick Tidyverse code to it, we can say, take this data, filter it, so we're only looking at the year 2018, and then take that data and group it by age group, and then summarize it where we want the mean is equivalent to the mean of the income. And this gives us that whole large data set down to just the mean by group. So we're grouping it by age. So less than 18 gives us 21,000, greater than 60 gives us 73,000. And this is kind of the core example of the Tidyverse, is you're kind of working through examples from data, applying some functions that look like verbs, and then getting an output. I'll be going through each of these different examples as we move forward in terms of where these functions are coming from and what they actually do. And that's the Tidyverse in terms of very verb-based, very readable, and you're kind of understanding exactly what's moving forward. And even if you didn't necessarily know how to code in R before, it's hopefully fast to pick up because it is verb-based. So the Tidyverse itself is an opinionated collection of R packages for data science and data analytics. All the packages share an underlying design philosophy, grammar, and data structure. So there's consistency across all these different kind of approaches to working with data. The core packages are going to be readr, Tidyr, Dplyr, and ggplot2, which kind of form this picture of taking data, bringing it into R, tidying it up, so cleaning it up, transforming that data, so maybe converting something or changing the type of data, visualizing it, modeling it, and trying to get an understanding of it, and then send that out to communication to stakeholders or to ourselves. And this is kind of the core tenet of the Tidyverse, is you can kind of work through this process in a consistent way. The Tidyverse itself is an R package. So if you're trying to use it in the wild, you need to do two things to be able to use it. You'd first need to install that package's Tidyverse, which would download and install the Tidyverse from CRAN, which is a source of all the R packages that have been published there. And then once you've downloaded it, to actually start using it, you need to load it into your system. We do this with the library call. So we can say library Tidyverse, which loads and gives you access to all the Tidyverse packages. The examples I'm going to give you in the RStudio cloud environment, you won't have to actually download anything, but you would need to do some of these steps that are given in that cloud example where you do load the library. Again, the Tidyverse core principles, it's built around data, usually as a data frame or tibble, which is that rectangular data format where you have columns and rows. And tidy data really means three things. It means each variable is in its own column, so you have one variable per column, not multiple. Each observation or case is in its own row, so that means each of those columns then have an observation or case specifically in a row. And then all these observational units form a table, which is, again, the data frame or the tibble. So if we look at this in more graphical format, we have variables and columns, observations and rows, and valuables within each specific row, which is an interaction of the column and the row. Now, this might seem kind of abstract. You're like, okay, maybe I need a better mental picture of this. If we look at an example of untidy data, it may make more sense, and then we'll move forward towards tidy data. So in this example, we have a tibble or data frame here where I'm looking at the columns. So we have age group, male 2016, female 2016, all the way out to male 2018. This is untidy because in the column names, we actually have a variable. So we have male and we have 2016. So this is what we like to call wide data in terms of it's pretty easy for you to type into Excel and you're kind of moving along as you go by increasing in year. But for you to analyze this, you'd actually need to make it tall data where you're taking that 2016 or year variable and putting it in its own column. And this is an example of what that tidy data would look like. You've basically moved year from being in a column title into its own column. So now we have male in its own column, female in its own column, and then year moving down in its own column. So when you work with this, you can actually do all these operations on the specific column rather than in this wide data where things are distributed in multiple columns. We do this with a function called gather, where it actually takes the data and shifts it from wide to a tall format. And if we did this first step, we would gather, we get male 2016 through through female 2018. So we take those columns and we gather them down, so it actually pivots it to a tall, and it changes the column name into this column here. But you can see that the column is still male in 2016, so we need to split that or separate it out into its own column, because we want a gender column and a year column. So if we do separate, we take our untidy data frame, we gather it to be tall, and then we separate our gender year column into two new columns, gender and year. We can see it takes that and then splits those two columns into the respective columns of gender and year. And it still keeps all the rows that are appropriate for that group all connected. So now this is ready to go for tidy data. I'll be talking about some more of this, but just kind of the idea of tidy versus untidy data and why we focus on it so much, that's kind of the concept. So you can read data in with a bunch of different packages within the Tidyverse. So readr, Haven, and readxl, which give you access to things like CSVs or tab-separated files or delimited files. You can also read in things from SAS or SPSS, Stata, DTA. And obviously, if you work a lot with Excel, you can read in Excel files, whether they're XLS, XLSX, or just general Excel files. But all of those can be read into R with these libraries in the Tidyverse. The kind of main player of the Tidyverse in terms of working with data is Dplyr, which gives you 6 main verbs. Filter, which actually filters data according to some variable you choose. Arrange, which arranges the data in either ascending or descending order according to what column you choose. Select, which selects a subset of different columns. So say column 1 or column year and gender, you can grab those with this. Mutate, which changes columns. Group by, which assigns a grouping variable. So you could say, group by gender and age group, and then you apply the different functions in that way. And then summarize, which takes a large data set and summarizes it down to a summary function, like mean or median, standard deviation, something like that. There's also some things I'll show for simple use, things like pull, which pulls out a vector, in and count, which count observations, and then glimpse, which gives you a nice clean overview of the data set you're working with. There's also some advanced iterations that I'll show briefly and you can follow up with, which would be, rather than calling multiple summarize or mutate, you can actually tell it to do those same functions at multiple columns all at once. And if you want some more information, you can go to dplyr.tidyverse.org or the free R for Data Science book. So first off, we're going to start with the empty cars data set, which is initially a data frame. So if we look at the class of this is just built into R, this data set is. We can say this class is a data frame. So it's in that tabular format that we're used to with columns and rows. Alternatively, a lot of the things in the Tidyverse work with tables, which is basically a table. It's a play on words for this is a table, but it literally looks like tibble. And if we take this class here, it's still a data frame, so it looks the same, but it has some nicer changes to it in terms of how it prints and how it operates. So if we call the initial empty cars data set and we just read that out, you can see that it gives you your columns and your rows, but it doesn't tell you anything about what these columns are. Like you can probably infer that this is numeric, and maybe this is a factor or a categorical variable, but it doesn't tell you that. If you then call it, look at the empty cars as a tibble, you can see that it gives you descriptions of this. So it says the tibble has 32 observations by 11 columns, and each of these different columns here have an actual type. So this is a double or numeric, and all of them are actually double or numeric. So if you were to change these to say like a character or a categorical factor, you could also see that here. Moving forward for these examples, I'm going to assign empty cars to be a tibble. So when we print it and work with it, it'll show up in this way, which is a little bit cleaner with the examples here. If we do the function head on empty cars 5, we can see that it takes the first 5 observations of empty cars. So this is an example of like you pull a data set into R and you just want to quickly take a look at it. Just do head empty cars and then set a number. This could be anything 1, 5, 20, and it will print out that number of observations starting from the top. Alternatively, you could do tail and do the same thing, but now it's going from bottom to the top. So these are the last 5 observations as opposed to the first 5 observations. You can also use the slice function, which grabs different rows by position and space. So this takes the empty cars data sets and slices it, so we're only looking at rows 1, 2, and 3. So columns 1, 2, and 3 are here. I've highlighted rows 1 and 3 because I'm also going to show you an example of taking rows 1, 3, and 5. We can see 21, 22.8. So this is actually row 1, row 3, and then row 5. If we use glimpse, we get kind of an overview of the whole data set. So how many observations, how many variables, and then it gives you the first few examples from each of those columns, as well as the category type of the column itself. So again, doubles all the way down. The first kind of core function we're going to look at for Dplyr is filter. So again, this filters the data set based on some variable. So if we take the empty cars data set and filter it where cylinder is equal to 8, it only gives us observations where cylinder is equivalent to 8. Importantly, you need to use double equals here because a single equals would be read as assignment versus double equals is a kind of variable and saying, is cylinder equal to 8? You could also do something here where you actually take a cylinder and you want to see the cylinders that are equivalent to 4 and 6. So you could use this in function along with a combined vector of 4 and 6. And now it's basically excluding everything that's not those variables. So cylinder has to be 6 or 4. And you can see all of our cylinders here are 6 or 4. You can also do cylinder not equal to 4. So in this case, we're taking any variable that isn't 4 for cylinder. So we can see only 6s and 8s in the first few observations here, but throughout the whole data set, 4 is basically excluded. The next function from Dplyr I'd like to look at is arrange. So in this case, we're arranging the entire data set by miles per gallon. So if we look at this data set, it's now looking at the lowest miles per gallon, so 10.4, and then it will continue going down in ascending order according to the miles per gallon. If you wanted to look at, say, the highest miles per gallon, you could instead do descending. It defaults to ascending order, but in this case, we can look at ascending. And if we do descending miles per gallon, we can see it starts at the highest value of 33.9 and then goes in descending for miles per gallon. We can also do this according to multiple variables. So we can look at descending cylinder and then descending horsepower. So it'll first sort the data set by cylinder value. So 8 is the highest number of cylinders. And then within each of those, it will also arrange by horsepower. So you can see that within the 8-cylinder variables, we have the highest horsepower descending. And if we looked further, it would switch over to 6 and do the highest horsepower, and then switch over to 4 and do the highest horsepower. So there's ways of kind of iterating across these as you move forward. You can also use the select function from Dplyr, which selects only those variables. So if we take the empty cars data set, we select only cylinder, miles per gallon, and cylinder. And when we take a look at it, you can see that we now only have those 2 variables. So if you had a really large data set and you wanted to look at only a few variables, you could do that quickly with select. You'd also select multiple variables, so displacement, cylinder, horsepower, and miles per gallon. Now you have those 4 columns selected. And then lastly, you can also select a few columns and then drop a specific column. So now we're saying, select these 4, and then we're going to drop miles per gallon. So we can see here, we're using the same code, but then adding the minus miles per gallon, which actually drops miles per gallon from the data set. All of this is temporary in terms of, because I'm not reassigning this back to empty cars, these are all just evaluated and then dropped. if you wanted this to actually overwrite, you should reassign this back to the empty cars data set with the arrow. And then lastly, you can look at the everything function. So let's say I just want to put cylinder and horsepower at the start in terms of the columns, and then take all the rest of the data columns. So we're putting cylinder and horsepower at the start, and then everything else gets put behind it. And then lastly, we can also look at other kind of helper functions. So if we wanted to select columns that started with C, as well as columns that started with H, we can see now we've only got a few columns. We've got cylinder, which starts with a C, carb that starts with a C, and then horsepower, which starts with an H. So there's a lot of different ways of selecting columns if you have a lot here. The next big part of Dplyr is mutate, which again transforms or mutates columns and the rows that are within that column. So if we look at just the cylinder column, we can see that it's double, basically is numeric. If we then change it and we mutate it where cylinder is now a factor or a categorical variable, we can assign the cylinder column to have levels. So 4 is less than 6 is less than 8. And we can label these categories as 4-cylinder, 6-cylinder, and 8-cylinder. Then we select the cylinder and take a look at it. We can see it's now a factor as opposed to a double. And it's got these nice descriptive labels that says 6-cylinder, 6-cylinder, 4-cylinder, which matches up with the actual data underlying this, just moving it from a numeric to a factor. We also look at mutating with math. So maybe you want to look at miles per liter instead of miles per gallon. So we can take the miles per gallon, we can take empty cars, and then mutate to give a new column, which is miles per liter, which is equivalent to miles per gallon times 3.78. And that gives us our miles per liter, which is about 79.5. We can then return this back into miles per gallon by taking the new miles per liter column and dividing it by the same number, which gets us back to either miles per gallon or miles per gallon are equivalent. These mutate functions are very powerful, but sometimes we want to specifically change things by a group. So we can use this with the group by function. So by itself, the group by function really doesn't do anything. It just assigns a grouping variable to the data set. So if we group by cylinder, we can see that it's added a new kind of descriptor here. The group is cylinder, and there's 3 levels because we have 4, 6, and 8. But if we combine the group by function with something else, like slice, it'll now take the first observation from each of the groups within the empty cars data set. So we can see 4, 6, and 8 for the cylinders because that's the grouping variable. We can see the group is here. And it's taken the first observation from within each of those variables. We could also filter within a group. So let's say we want to group by cylinder again, and we want to filter to get the max horsepower. So within each variable, so 4, 6, and 8, what is the max horsepower we see? We can see that the 4 cylinders have a small horsepower and the 8 cylinders have a high horsepower. So you're getting a useful output here of the group by combined with a filter. You could also do something like top in. So this will give you the same output, but you're taking the top observation of 1 within the horsepower column. So again, 113 for 4 and then 335 for 8. But just specifically saying that you're doing these according to the grouping variable, which is cylinder. The next option is arrange. So if we did group by cylinder, arrange descending horsepower, and then sliced it, we would get the first observation, which would, because we're sorting it within a group by descending horsepower, we're actually again getting the highest horsepower within that group. So you can really see how you're combining different things to get these powerful outputs that are similar to each other. And lastly, if we did something like group by a cylinder and type of transmission, so automatic or manual, and then counting, we get a nice table where we see for 4 cylinders and manual transmission, we have 3, 4 cylinders, and automatic transmission, we have 8. And it provides this count by group. So this would be like a group by count for all the different combinations of these. So combination of 4 and 0, 4 and 1, 6 and 0, 6 and 1. So you can do as many different columns as you want here within the group by, and it will iterate across those and then call the next function you're looking at. Another powerful function within Dplyr is summarize, which basically collapses the data set down. So we take empty cars and we want to summarize to get the mean. So now we're saying empty cars and then summarize, mean is equal to the mean of miles per gallon. So we can see across the whole data set, the average miles per gallon is 20.1. And I'd be saying, well, why do I need summarize? Why don't I just do empty cars mean? Because mean is looking for a vector of numbers as opposed to a column. So if you did something like empty cars and then piped it into mean miles per gallon, it'll actually give you a warning because it's not inputting the correct number. You could do something like empty cars pull mile per gallon, which takes out that column as a vector, and then take the mean of it, which gives you the same number. Or you could use alternative syntax within the core part of R to do this, but then you're kind of avoiding the summarize function. You can also use the summarize without labeling it. So if we take empty cars and summarize to get the median of miles per gallon, we didn't label this because we didn't have a median equals to something, but it still ran it. It just gives us this output of exactly what it did, as opposed to labeling it where we say median miles per gallon is equal to, this should be median, not mean, but median miles per gallon. And it has a label here as opposed to here where it just kind of has exactly what the code was. Summarize gets really powerful when you start combining it with a group by. So now we're taking empty cars, grouping by cylinder, so 4, 6, and 8. We're taking the mean miles per gallon, the standard deviation of miles per gallon, and then the number of observations of each of the different cylinders. So we can see that the most cars were 8 or 4 cylinder, and that the 4 cylinders have better gas mileage than the 8 cylinder cars, but the smallest standard deviation was actually for 6 cylinders. But again, it's iterating across each of these groups and calculating the mean only for 4, only for 6, and only for 8 all at once. I'd like to quickly go through the mutate add function. So we look at the variables of interest. You can say, rather than typing out all the different ones, you can say, I want the variables that are cylinder and automatic transmission. I'm going to mutate those to be factors. And if I look at them, they're now factor equivalents. So this would be the same as saying mutate vars equals factor cylinder and automatic transmission equals factor automatic transmission. But this kind of does it in a more compact way. And this is equivalent to, you can see that this is a factor as opposed to if you didn't change it, it would still be a double. You can also do this with summarize at, in terms of you have the variables miles per gallon, displacement, and quarter second mile time. We're going to take these variables and summarize them by group, and we're going to take the mean. So it does it for all these variables, so miles per gallon, displacement, and quarter second, and we get the mean according to group for all these different variables all at once. So again, combining things makes them more powerful. And you could even do this with multiple functions. So the same column, so miles per gallon, displacement, quarter second time, and we get the mean and standard deviation time. So it's calculating, okay, we messed up there, so we'll move forward. Yeah, should have worked there. And then moving on past Dplyr, we've kind of looked at the different ways you can transform data. Tidyr is used to clean up data or tidy it, so move it into this tidy data structure where each variable is in a column, each observation is a row, and again, each value is a cell. There's basically 2 main parts to this. So make data either taller, which is gathering, or making data wider, which is spreading. So this takes 2 columns and either makes them taller or wider. And then the other option would be separate and unite, which takes 1 column via separate into multiple columns, or unite, which takes those multiple columns and combines them into a single column. This allows you to move between wide and tall data and kind of tidy and untidy data quickly. Tidying the data. So again, going back to our previous example, we can see that the untidy data frame has variables in the columns. So male, or gender and year are here, where we want gender to be in its own column and year to be in its own column. So if we do the gather function, we can gather the gender year by income. So this would be the key. So the column is gender year. The value is actually income. So all these different observations within each column are income, but we don't have that column yet, so we're creating it. And we're taking all the columns from male 2016 to female 2018. So if we look here, male 2016 all the way out to female 2018, which is here. So we do that, we've now, again, pulled it into a taller format. So we have gender year, because that's what we've created, and then income, which is the value that's actually within each column. We now need to separate gender year into gender and year columns. So we can do this by using the separate function. We separate gender year into gender and year columns. And this has now taken gender and year and split them out. So gender's in its own column and year's in its own column with income. The opposite, kind of taking tidy data and spreading it out or separating it into untidy data, if you need to use that for another function or for an output or saving it for some reason, you could also unite. So you could create a new column, gender year, where you're combining the gender and year column, and you're adding this separator of an underscore. So we do this, it moves us back from our tidy data set into a single column of gender year, which is again the combination of gender year, and we've input an underscore between each of the variables. It's still keeping all the observations appropriate to each of these variables. And then we can take it and put it back into a wide format with spread. So we can spread gender year and income. So we split it out, and again, we get back to male and female along with the year in the column title, and then the income is the value within each of those groups. The last part I'd like to talk about quickly with the Tidyverse is ggplot2, which we could talk about for hours, and I'll try and give you a quick run through of ggplot2, but it's the plotting and graphing library from the Tidyverse. Basically allows you to create these robust and beautiful images, as well as do quick exploratory data analysis. So you could use piping or create a plot and save it for an output, or you just quickly kind of iterate across data sets to explore them. The three core parts of ggplot are the ggplot call, which actually builds the base layer, geom, which assigns the shape. So maybe you want to make a point graph like a scatter plot, or a line graph over time, or a bar or column, or even a statistical output like a box plot, a histogram, or density. There's dozens and even hundreds of different geoms that you can create, both from the Tidyverse team and from other people who have contributed. Lastly, the other part would be aesthetics, which is basically the mapping or relationship. So if you think about the core plot, the shape of the graph, and then the aesthetics are things like the x coordinate and the y coordinate, or maybe you're assigning a variable to color or shape or larger size, smaller size, transparency. Overall, it's just relationships. This might seem a little abstract, but I'm going to jump into some examples to show you what this looks like. So the basic ggplot call will look like this. ggplot is the main function. The data is going to be equivalent to some data you're putting in. The mapping is equivalent to some aesthetics that you're specifying, where these mappings are input. And then you're telling it what type of geom you're going to create, or what type of graph you're going to create. So if we go to example back to our empty cars data set, the data is going to be empty cars. The aesthetics are going to be x-axis is going to be cylinder, y-axis is going to be miles per gallon. We're then going to add to that the geom point call. So we're going to make a scatter graph where each of the observations are equivalent to a single point on the graph. And so we can see quickly that we've created a graph of cylinder on the x-axis and miles per gallon on the y-axis. So you can see there's a couple observations within each variable here. So the x-axis of cylinder and y of miles per gallon. I do want to specify that, you were like, okay, well, there's this plus symbol. Rather than using piping within ggplot, it uses the addition of new points because it's all kind of contained within a single ggplot. So make sure that you use a plus here and not a pipe function. So again, we're supplying data, we're telling ggplot2 the aesthetic mappings, and then we're adding layers of plots on top of that via geom calls. As I mentioned, there's so many different types of graphs you can create with ggplot. I'm not going to read through these, but just an example of all the different options that you could create. There's obviously some core graphs that you might use in your day-to-day, or if you're creating graphs for a report, things like scatter plots and bar plots and line plots are very common, and those are easy to do in ggplot. So for the ggplot walkthrough, I'm going to use the Gapminder data set, which is a few different variables about the world. So we're looking at different countries across time, continent, and then the data sets we have about them are their life expectancy, population size, and then the GDP per capita. So we're going to save this data set into R as Gapminder data frame. And I've taken a quick look at it so we can see there's 1,700 observations and these 6 variables of interest. So I'll be using this for all of the ggplots moving forward. So if we quickly take this, we can say the Gapminder data frame, we then filter where country is equal to Malawi, and then we take a plot of it. So it knows that the data set coming in is going to be the data only where country is equal to Malawi, and we're going to assign the aesthetics where X is equal to year, Y equals life expectancy, and then we create a line plot where we want the color of the plot to be this hex code, which really is just blue. And we want it to be wide at 1. If we look at the actual plot, we can see that over time, we see an increase in life expectancy, which is a great thing. So within this country, life expectancy has increased from about 35 to 50 with a little dip here recently. But just that was the quick ggplot, is if you wanted to, just assign the aesthetics of X equals year, Y equals life expectancy, and you could stop this at just GM line, but I chose to change the color and make the line a little bigger. I could also overlay points on top of this. So I've already created the line plot. I could just add another GM point with size equal to 2. So now we've added a point for each of the observations of the data set, where the line is connecting these points on the graph. And hopefully this is readable in terms of you kind of see, okay, this is what I'm building up. I'm going to take my data of interest with some Dplyr code, and then I'm going to assign that to my X and Y axes, add a line, add a point. So it kind of iterates across in a logical way. Moving on to a different example, I'm now going to filter where I have 2 countries. So I have China, and then country also equal to United States. And then I put this into ggplot. We're using the same thing where we see an x-axis equal to year, a y-axis equal to life expectancy, but now we're also assigning a aesthetic of color is equal to country. So it'll look through the whole data set and assign a color to China and a color to United States. You can see here on the legend, it's assigned red to China and blue to the US. So when we build out this plot, not only is it assigning the X and Y variables, but country is being used as a variable within the plot to assign color. If you had 10 countries, it would assign 10 unique colors to each of those different countries. Another example real quick would be doing a different thing. So we have aesthetic of year, aesthetic of country, so X and Y variables. We want our color to be equivalent to country. So again, United States is blue, China is red, but now we've assigned size equals to life expectancy. So each of these points just means that as it gets larger or smaller, that's a larger life expectancy or smaller life expectancy. This is not a great graph. I just want to hit on the point that you can assign a bunch of different things to be an aesthetic. So it doesn't have to be just X and Y coordinates. You could change, in a scatter graph, you could have dots get bigger or larger according to a third variable or even a fourth variable. If you wanted to create a bar plot, we could do that with some example code here. So now I'm taking I'm taking a data set and filtering where year is equal to 2007, continent is equal to Africa. I'm going to then arrange by descending life expectancy. So what are the highest life expectancies for the African continent in the year 2007? And then just take the first 5 observations. I'll assign that to this bar df data frame. And then I'll call some ggplot code on it. So now rather than piping it, I'm taking ggplot where data is equal to bar df, which we've created, and then assigning the aesthetic of x is equal to country. So we have the country names on the x-axis, and y equals to life expectancy. So we can see the different life expectancies for these groups, which is about almost 70 plus for all these countries, which is great. But I guess importantly also, you're also seeing that this ggplot has been assigned to an object. So I'm calling the bars object to create this plot, as opposed to before I was not really assigning, I was just kind of iterating across. You'll notice I use the geom column call, which basically says, create a column or a bar plot. If we use a bar status here, we actually need to identify that the stat or the statistic is going to be identity, which basically means it's the actual value that R finds. If we want to avoid having to do that, we could just use a geom column call, which automatically knows to look at just the value that's within the data set. So, 72, 75, 72, 77, 76. It knows that the value is actually what we're trying to plot. You can also create a grouped bar data frame. So if we create this object here, grouped bars, we're taking a grouped bar data frame. We're assigning X to be country, Y equals to life expectancy. We're creating a fill, so we're actually filling the interior of the column as opposed to the color with year as a factor. And then we're creating a bar on top of it where, again, the stat is equal to identity, so it's the actual value, but we're also assigning position equals Dodge, which gives you this grouped bar chart where you have within Indonesia the year 1967 and 2007, and it does the same for each of these different groups. But really the big player here is position equal to Dodge. There's lots of other kind of arguments you can make here, but just as a quick example of a grouped bar chart, which is pretty common in visualization. You can also create statistical outputs, things like histograms. So again, we're taking the Gapminder data frame, filtering where year is equal to 2007, and across all the different countries, we're just looking at the life expectancy. Because a histogram is already assigning a Y variable, in this example, it's counting, we only have to assign the aesthetic of X equals to life expectancy. So we're really only assigning the X variable, and then ggplot counts all the observations at each of those different bins. And if you're familiar with a histogram, the bin width is basically how wide this is. So this is like 70 or 67.5 to 72.5. So basically 5 units across. And then we're doing color equals to white. So we have these separations between the bars. And then we call the plot and it builds it out for us. We can also kind of pretty up the graph in terms of changing the X and Y labels and adding a title. So you can see here it says life expectancy. There's no spaces. It's lowercase. We actually change all this. So we can add life expectancy is years. We see life expectancy in years. We're going to label the y-axis with count. So this is equal to count. Add a title, so life expectancy for the title, and then a subtitle of year equals to 2007. And then source it. So we add a caption of source equals Gapminder. Basically, you can put any text you want in here, and it will put that in the different locations. And we're just having to wrap it all in this labels call. Because I saved my histogram earlier as histogram plot, I can actually just add all these things to that pre-built plot, and it already builds out the graph. So I don't have to recall all of this. It's already saved as histogram plot, so I'm just adding these labels to that plot. And then lastly, if you want to save some output, so it's great to see it inside R and RStudio, but eventually you want to save it out to be somewhere, whether it's on your desktop or putting it into a report. So you can save the file as this name. So this is the life expectancy in 2007. We want to save it as a PNG file. This is the actual plot we're saving, which was that plot we saved as histogram plot. Height equal to 4, width equal to 6, and then the units are in inches. So this makes a 4 by 6 inch plot with a dots per inch of 450. To kind of break all that down, you're just saying that you want to save a 4-inch by 6-inch, kind of like a normal picture size, and the DPI basically means that it's higher quality, so it's more pixels per inch. If you didn't specify this, it might be a little fuzzy, but because we've specified the DPI to be pretty high, you can see it's really sharp. So all the different lines are very nice, and there's not kind of jagged edges to anything. This code here is just actually reading the file back in really quickly into the graph here. There's so many customizations you can do to ggplot that I'm never going to be able to cover them today, and I don't want this to overwhelm you, but just if there's something about the plot you want to change, you probably can. And all these different arguments can be made to create exactly the type of plot you want. Kind of a cheat of not having to specify all this is using something called a theme. So a saved theme applies all these different elements all at once. So this saves you a lot of writing. It allows you to be more reproducible in terms of you don't have to send around some code. These are already built into ggplot. So you can use themes like theme gray, theme black and white, theme minimal, and theme classic. All these, when applied, kind of change the look of it. There's also other packages like the bbplot package, which is actually created by the BBC News team, which applies their specific style. The Urban Themes, which is another data analysis company, so they have their theme Urban Print, which changes the themes to look like their types of graphs. And then the GG Themes package has things like the Few Research Center, Excel style plots, or even things from like The Economist. And if someone's looking forward to it, they can actually build your own package or theme to specify according to the BLS in terms of what they want to see. So we build out kind of a normal graph here. So this is, again, the gapminder data frame. We're filtering where China and United States are the countries of interest, and then creating our plot. So this looks exactly like the plot we built before, because theme gray, when we assign this at the very last point, is actually already the default theme. So it literally isn't changing anything. But if we change the theme to say black and white, you can see that it drops the background from gray with white lines to white with gray lines. So okay, I mean, that's cool, but it's not a huge change. You can also do something like theme minimal, where it drops the X and Y axes lines themselves. And so maybe this is more aesthetically pleasing to you. You just kind of choose these according to what you like or what you're trying to build. You also do theme classic, where it completely drops the major and minor grid lines, which are shown here. And it just gives you back your axes lines here. So you kind of have a nice clean plot with a lot of, not a lot of ink wasted. And then if you look at other packages like GG Themes, the exact same plot with a theme Economist, this is similar to the plots you would see in the Economist articles. So a gray background with a white background on the plot area. They also have a different variation where it does blue instead of the white. You also do it from the Few Research Center. So they have no grid lines, but they do have a full line around the box. And then the one I really like is the bbplot style. So this is from the bbplot package. It applies BBC style, which from my quick overview of some of y'all's graph on your own website, this is pretty similar to a lot of the graphs I saw there in terms of you don't have vertical grid lines, but you do have horizontal grid lines. And then we're also adding a horizontal line that's black right at 0. So it zeroes out the graph and gives you kind of an axis to follow along. So this looks really nice to me in terms of it's pretty aesthetically pleasing, and the bbplot group actually has a cookbook basically showing how to do all their different visualization styles that I'll share with Mike later. You can actually recreate a similar thing to the BBC plot with just changing the theme. So panel grid major, panel grid minor X, we're actually making those element blank, so we're removing them completely. We can see that these are somewhat similar, although the bbplot is changing things like the size of the text on the X and Y axes, actually changing the font, as well as the legend position being on top as opposed to on the side. So this is why I say it's kind of easier to use those pre-built themes or someone else's theme rather than having to type out all these different elements, but you could create this yourself. I know that we've covered a ton of information and it was probably pretty quick. I will be sharing a video as well as some practice material with your group. But basically, again, the Tidyverse focuses on this tidy data format because it's easy to iterate with these different verbs we use. So Tidyverse reads in data with readr, tidying data with Tidyr, transforming data with Dplyr, and then plotting data like we saw most recently with ggplot2. The next steps for your group is the R for Data Science book, which is actually online for free. So you can read through and see both example code and kind of why you're doing it things, and clicking around, just kind of more of a textbook style rather than a presentation. And then the RStudio Cloud primers, which you can click here on the PDF that Mike sent out, which is examples you can run right in your browser. So if I show you these real quickly, this is RStudio Cloud. When you log in, you can just go to primers. This is all free. And you can click on things like, well, let's say visualize data. And it has these little lessons here where, zoom in a little bit. You can do exploratory data analysis or bar charts, box plots, scatter plots, whatever you want to learn. You can click on it. It will load in an RStudio environment for you to work with. You don't have to install anything. And it has kind of like this guided tutorial that walks you through how to create things. So it gives you example code, shows you how to do it, changing the aesthetics and showing you what the count looks like, as well as like faceting and other things I wasn't able to cover all the way through today. So this would be a great resource for kind of next step for your group, although I will be giving another presentation with your group in August about R Markdown, and I'll be using some similar material. That's the end of my slides. So I know we're kind of at time, but if y'all do have any questions, I'll unmute everybody, or we can ask questions here in the chat. I do have a little bit of time to chat with y'all if y'all do.
Okay, thanks, Thomas.
Yeah, thank you so much for your time. Sorry if it was all a little quick. Just wanted to cover as much material as possible.
Oh, that's okay. Any questions? Okay. There's none at this time, but I'm sure I may get some emails.
Sounds good. Yeah, feel free to send them my way. As I said, I shared the slides and the primers. They're linked here within the actual presentation. But thank you so much for your attendance today, and y'all have a great rest of your week.
Thank you, Thomas. You too.
Yeah, bye.
Bye.